right, so these notes are over interpreting slope. Okay, so what does slope mean in real world situations? So once again, I know that slope is represented by the letter M, okay, the variable M. I know that it is rise over run. It is also change in Y over change in X. Okay, for the purpose of this worksheet, it gives us 2 points. So I am actually going to use slope formula, which is going to be y2 minus y1 divided by x2 minus x1. So I'm going to use my slope formula here. All right, this first problem is already worked out for you. I'm just going to go ahead and go through it real quick. And then I will do the first practice problem for you, and then you'll work out the second one on your own. So it says, example, the graph shows a relationship between the time worked, which is my x-axis here, and their money earned, which is along the y. Okay, so time worked, money earned. It says you can use the 2 points to calculate the slope of the graph. Okay, so the first point it gives you is 4 110. So I have 4 110. Second point it gives you is 8 170. 8 170. Okay. And if it didn't give me these points, I could use this line and where these intersect in order to figure out 2 points. But we're lucky here because it gives you 2 points. So it says we're going to use the slope formula. Okay, we do have our star charts. We're about to start using those very, very soon. Okay, and you'll get very used to slope being on that star chart. So as we set this up, I have M is equal to y2 minus y1. They've already labeled these for you. We don't have to label these ones. So my y2 was 170. My y1 was 110. Okay, my x2 was 8, and my y1 was 4. So on top here, in my numerator, I have 170 minus 110, which gives me 60. In my denominator, I have 8 minus 4, which gives me 4. Okay, this is not yet simplified. Okay, if I was to plug 60 divided by 4 into a calculator and hit Math 1-1, I would get 15 or 15 over 1. Okay, so we're going to go ahead and talk about our variables that it gives us here. Okay, I know this is going to be my x and this is going to be my y. Ooh, that was terrible. We're going to cross that out. My y there. Okay, my x and my y. So, similar to change in y over change in x, I know that as far as my variables, my relationship I have here, it is still change in y over change in x. So what this tells me is that it's 15, which goes to my change in y. So it's $15 earned, okay? $15 earned all over, okay, my change in x, which it says is hours worked. So I have hours worked. Okay, in a real world example like this, I would get in the habit of writing your x and y here. So I have my change in y, which is money earned, and my change in x, which is hours worked. Okay, so if we are going to interpret the slope of 15, because I know that 15 over 1 is the same as 15. The slope of 15 means that for every 1 hour worked, okay, 1 hours worked, their money earned increases by $15, okay? The slope of 15 means that for every 1 hour worked, okay, which is our x down here, their money earned increases by $15, which is our y up here. Okay, you've got to remember to label your change in y up top and your change in x on bottom. all right, when we're interpreting slope, all right? So now let's go ahead and do this practice problem, all right? Practice question we have here. So here we go. It says the graph shows a relationship between, okay, on my X down here, and I have my Y right here, it is peanuts, and I'm going to go ahead and label this as my X-axis here. Okay, that is peanuts is what it gives me. The relationship between peanuts and jars of peanut butter. Okay, that's what my Y gives me here. So that's going to be my Y axis. Okay, not a bad idea to get in the habit of labeling these, just like it did on the example above. It says, at time worked, X-axis, their money earned, Y. Okay, so we're going to continue that same habit. So, peanuts, X-axis, jars of peanut butter, Y. All right, so it says use 2 points to calculate the slope. So here, I've got to label my points because we've got to remember that's super, super important. So I have X1, Y1, X2, and Y2. Okay, X1, Y1, X2, Y2. All right, that goes back to our previous slope notes. Okay, I know our slope formula is going to be Y2 minus Y1 all over X2 minus X1. Okay, that's part of our notes part of this. So I'm going to plug in these points here. So Y2, it tells me is 7. My Y1, it gives me is 2. So I have 7 minus 2. All divided by my X2 is 3,360 minus my X1, which is 960. Okay, so now I've plugged in my 2 points into my slope formula. Now I've got to go ahead and simplify this. I have 7 minus 2, which gives me 5. On bottom, I have 3,360 minus 960, which gives me 2,400 as my denominator. So I have 5 divided by 2,400. If I was to plug this into a calculator, I could very easily figure out that this is not simplified by using my math, enter, okay, on my calculator to get the fraction 1 over 480. Okay, my simplified fraction. I can plug 5 over 2,400 into my calculator, or 5 divided by 2,400 into my calculator, hit math, enter to get 1 over 480 as my simplified fraction. So, similar as what we did earlier, I'm going to go ahead and label my 2 relationships there, my variables. All right, so on top, I know it's my change in Y. So, this 1 is going to represent jars of peanut butter, and I'm running out of room there. So, PB, jars of peanut butter. On bottom, I know that this 480 is going to represent the number of peanuts. Okay, and I still have this information here. My jars of peanut butter goes on top because it's change in Y. My number of peanuts goes on bottom because that's my change in X there. Okay, so now we've got to actually interpret that slope. The slope is 1 over 480. Okay, so what in the world does that mean? It takes 480 peanuts, so I have 480 peanuts, because that's what I have down here for my X, to make 1 jar of peanut butter. Okay, I'm interpreting my slope there. For every 480 peanuts, I get 1 jar of peanut butter. Okay, or for every 1 jar of peanut butter, I have to use 480 peanuts, whichever way you want to read that. But I have to make sure that the peanuts goes with 480 and the jars of peanut butter goes with that 1 there. I've got to label my Y on top and my X on bottom. That has to stay consistent. All right, so just as a quick recap, up at the top, I know that slope, which is represented by M, is rise over run, which is my change in Y over change in X. So M is Y2 minus Y1, which is my change in Y, over X2 minus X1, which is my change in X. Okay? I label my X and my Y. All right? I label those variables with the axis there. All right? My points, I always label those. And then I've got to plug it into the slope formula. Okay? On top is my change in Y, which I have over here, which is going to be my dollars earned, over my change in X, which is going to be my hours worked, according to that. So I've got to make sure I label these correctly. Same thing down here. Got to make sure I have change in Y over change in X. Then we're just writing some type of statement to explain what that slope represents. All right? So at this time, I need you guys to go ahead and do problem number 2 in your journal. Okay, this one is the relationship between the cost of printing pages. All right, it gives you your 2 points and it tells you to label those 2 points. So you'll write what your 2 pieces of that relationship are, label them X, label them Y, label your 2 points. I plug them into my slope formula. After I plug it into my slope formula, I'll get my answer of a fraction. Then I'll write my Y variable, which should be cost, over my X variable, which will be pages printed. After that, you're going to interpret that slope. The slope is what? It costs what to print what number of pages. All right? Go ahead and get number 2 done for me. I'll have it posted later.